the area is 182 times 10 to the power 3. So the area will affect the what? Will affect the cost. Okay. In the world of materials, is sold by weight. The bigger the cross-sectional area means more expensive. Okay, so it will affect the cost. Then you look at depth, which is D, right? So you look at the depth over here, right, which is equal to D. Flange, now all of you know as a flange now, right? So this is the flange. So BF is the flange. The width, the thickness of the flange, that is your TF, right? Thickness of the web. Now you all know what's a web also. Okay. So the web is the vertical part. Okay, that's the web. Then you have IXX, second moment in the X direction. You also have IYY, second moment in the Y direction. Okay. So for your term test, we're only going to fix in the XX direction. I'm not going to do YY direction with you guys because I'm not taught you yet. Now, can you all see this? X as a function of X small x. So this S in the subscript of X, this S corresponds to this S over here. Okay, right. So now we know that our M max. So how to choose now? Okay, so we know that M max. Okay, so I'm going to look at M max. Okay, so M max we know is equal to 48 times 10 to the power 3. So this is calculated. We calculated it. Okay. And then we know that we are given that stress max is equal to, for this case, is 160 times 6 to the power 6. And how this is a material property. Okay, and is always given from material handbook. Or your supplier. Okay, so you're going to buy. Okay, can I have some allowable stress? Okay, so this allowable stress max allowable is after your safety of factor, right? So safety of factor, okay, is equal to stress ultimate or yield divided by stress max or stress allowable, right? That is your safety of factor, right? So from here, you know your stress max. So your stress max now is at 160 times 10 to the power 6. Okay, so now you can calculate your S, right? You can calculate. So S is equal to N max divided by your stress max, right? So your M max is equal to 48 times 10 to the power 3. Then divide by 160 times 10 to the power 6. So 48 power 3 divided by 160 power 6 is equal to 300 times 10 to the power minus 6. Meter cube. Okay, so what we calculated down here is meter cube. Okay, so why meter cube? Because this is Newton, right? Meter. This is Newton per meter squared. So that's why the units is in what? Meter cube. You can cancel the Newton down here. So it's meter cube. Now, if you look at the table is in, if you look at the table, okay, the units for the table, right, you can see down here, the units for the table is millimeters cube. So you have to convert. Okay, so the conversion is not difficult. So it's 300 times 10 to the power minus 6. So millimeter, right? So this is cube. You have to times 10 to the power minus 3 millimeters, right? Right. So 10 times 10 minus 3. So this will be equal to 300 times 10 to the power of minus 6. Okay, sorry, it's positive 3. All right, so cube times cube. So you multiply these two, you plus 9, right? Millimeter cube. So it's equal to 300 times 10 to the power 3 millimeter cube. That's how you do it. Okay, so you have to pick a beam now, right? That is the S is equal to 300 times 10 to the power 3. So you start looking now. Okay, so you start looking now. So you look at S. So I want you to focus your attention at W200. Okay, W235.9. Okay, so I want you to focus on. So what are the possibility? Okay, so I'm going to highlight the possibility. So the possibilities are this. So we can use this one, right? No, this is no good. I'm rather than drawing a box, I will highlight. I do apologize. Okay, so we can use this. All right, so the first one that we can use is this one. Where is it? Yeah, we can use this one. Can you all see what I'm highlighting? We can use this, yes or no? Right? We can use that one. Okay. Why we can use that one? Because the SX, right, is equal to 342, right? Because of this value down here. Right? You have to be above 300. Okay. Then you go up, is all above already. Then you look at W250. Okay, W250. We can also use this one. This one also can use. I think we can also use this one. Wait, where's my cursor now? We can also use this one. We can wait. We can also use above. We can also use this one. Right? Because of the 300, right? Right. So anything above is the higher you go means the bigger the cross sectional area. Then you can also use. We can also use. So the 300 is a control. Okay, the 300 is a control. The S is the control of the 300. We can also use this one, right? 415. You cannot pick the one below is because of it's 280, right? So the thing that you have to do with this, you have to look at your SX. Okay, you have to look at these two columns. Right, you have to look at these two columns. And what I've drawn horizontally are those that you can use. Okay. Now, which one to select? Okay. So remember I told you, the bigger the area, right, the more expensive it will become. Right. So we are going to compare area. So this is 4180. This is 3630. This is 4580. Right. So you have to select. Okay. You have to select. Okay. You have to select the smallest cross-sectional area when it satisfies the S value. Okay, right? So the smallest because it's the lowest cost, basically. Yeah, things are getting expensive now, right? So the one we have used is the W. So the selected one will be W 250 by 28.4. Okay, by 28.4. So that is all I'm going to teach today. Okay, so there is no time for another topic, so you guys are lucky. Okay, so if you look at the first page, okay, so this topic will not be tested at all. And I've already sorry, you can't see which topic. I've already, so the one I put cross will not be tested. I've already posted the homework. Don't do them yet. I will update the homework, and you guys do the updated homework. Okay, so because I put in the homework, I put centric unsymmetry bending moment for you guys. Don't do that. Okay, so just do the beams bending. So if that's the case, I'm going to stop recording. Okay.